Good morning, students. Today we will do exercise 2.2 and first question I did yesterday. So we have a few more good question in exercise. So let me take some question like third one. Question third says A is equal to 1, 2, 3 and 5 and B is equal to 4, 6, 9. Question is that a relation R is from A to B defined as R equal to xy such that difference between xy is odd. Difference between x and y is odd. This is a question. So lastly we are told to find its roster form. So I won't simply write here without wasting any time of it or taking any space that if you want to find the roster form, no formality here, that what is the roster form? It's following this one. A is 1, 2, 3, 5 meaning x element. This is definitely y element. And difference between x and y is odd. So, take one by one all the element. First should be x, second should be y. 1 and 4, 1 and 6, 1 and 9. But take such that difference between them is odd. So, 1 and 4, difference between them is 3. No, minus 3 or 3, no matter. The important is it should be odd. So 1 and 4 will be one of the pair. The difference between these two is odd. So 1 and 6, yes, it is also, because difference between them is a 5, which is odd. 1 and 9, the difference between 1 and 9 is 8, which is even. So we can't take this. So similar, I think you have got till now. 2 minus 4, 2 minus 6, both are even. But 2 minus 9, one should take here, 2 and 9. 3 and 4, one should take 3 and 4. 3 and 6, one should take also, because the difference between them is odd. 3 and 9, which is 6, which is even. Similar 5 and 4. 5 and 6. And 5 and 9 is definitely it's a 4. So whatever you are looking, this is actually a roster form of relation, whatever the tool in the set builder form. So I think not more than this I need to tell you, because question, the terminology is also very easy and answer is also very easy. Okay, let me wrap it. Now I go with the question number 4. Look at question number 4 in the book also. You also please see. Question number 4 is the figure 2.7 shows a relation between P and Q. This is a P and this is a Q. And this is 5, 6, 7. It is a 3, 4 and 5. And the diagram is given. And we are told to find the relation in set builder form, roster form, find the domain and the range. So whatever the picture is appearing, we just have to find the first. Look at what is this? This is nulls. It is a arrow diagram, and one know the meaning of this. Based on this, we have to form its set builder form. So it's very easy. First, I'll go with the set builder form. Set builder form. How it is? This is x, this is y, and search the relation between x and y. One can simply take it is x and it is y. Definitely it is a y. So y, and this number is 2 less than 5. This number is a 2 less than 6. This number is a 2 less than 7. So I would write this is y. So y is 2 less than x. Y is 2 less than x. y is 2 less than x. So I will write here that xy such that y is 2 less than x. Y is equal to x minus 2. And where x is where? X is in P. And y is where? Y is in Q. And that's an answer. Very easy. One can simply take the relation between these two. So this is y, this is x. I would speak y is 2 less than 5. Y is 2 less than 5. So easy that is. You just have to manage your writing in the separator form, and that's an answer. So what about the roster form? It's very familiar. 5 and 3. First, just see only the diagram you can catch. 6 and 4. 7 and 5, and that's enough. That's enough. That's enough. This is your which form? It is the roster form. And what about the domain and range? I need not tell you. Domain is equal to 5, 6, 7. Domain is equal to 5, 6 and 7. Range equal to 3, 4 and 5. And look at, if I ask you what the codomain, then codomain Q, which is actually equal to 3, 4, 5. Because only 3 elements are here, which is range actually. So range and codomain are same. Range and codomain are same. So I also taught you that range may equal to codomain. But range is also called subset of codomain. Range normally is smaller than codomain. So remember this all in mind. So it was so simple. It was a diagram was given and you just have to deal some question according to the diagram. Okay. Now let me move on to some next questions. Question is question number, look at 5. Question says let A is equal to 1, 2, 3, 4, 5 and 6, and the relation are defined on A, meaning A to A. Remember the language. The relation are defined on A, meaning A to A. And next is sentence is relation R is given like AB, where B belongs to A, where B belongs to A also belongs to A, such that B is exactly divisible by A. Try to understand the language. B is exactly divisible by A. And now you want to find here domain, range and roster form. So I won't waste time again. I speak already that what is a roster form. That is very important as far as the all remaining question is concerned. You can find out domain, range and all by forming the roster form. So first do try. Okay. Question says B is exactly divisible by A. I again let you know about B is a second element and A is a first element, and one should know A and B both are in A. We don't have a second set. Your relation is from A to A. So all the element 1 to 6, it should not go beyond it. First element is A, which is also in capital A. Second element is B, also in capital A. So B is exactly divisible by A, meaning second element should be divisible by first element. Okay, so start your writing. First I'll write 1, 1. Second element B, first element A. This element should, B is exactly divisible by A. This should divisible by 1, yes. What about next? 1 and 2. Second element is divisible by this. Meaning I'm making first with a 1. And try to understand it is what kind of picture. It is containing 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 like that. Like that. And I'm just making picture 1 with 1, 1 with 2, 1 with 3. Why? Because it all fulfilling the condition now. B is exactly divisible by A. second element is perfectly divisible by first element. So I'll write till 1 3, 1 4, 1 5, 1 6, 1 6, and now 1 completed. So go with 2. So match a pair of 2. So 2 1, can I write 2 1? No, because 1 is not divisible by 2. So what I'll write? Only 2 2, 2 2. 2 is a divisible by 2. Can I write 2 3? No, because 3 is not divisible by 2. So I'll write only 2 4, 2 4. And one can now understand it is 2 6. Now you can make by your own. 2. Now it's chance of 3. So 3, 1 I can't take, 2 I can't take, 3 3 I will take. 3 4 I can't take, 5 I can't take, but 6 I can take. Because it is divisible by 3. Now what about 4? So we are helpless because 4 and 4 only come. Because 4, then next will be 8. So 8 is not here. 8 is not here. So I can't write 4 4. Then 5 5. 5, then 10 will come, but 10 is not there. Then 6 6. So all these elements what are pairing, it is a roster form. And based on that, now you can find out your domain and range. So what is a domain? So domain will be first element. 1. We have a lots of time 1, but we can't write more than once. So if I find domain now, so domain will be 1. So all element having first element 1, now 2, 2, now 3, now 4, now 5, and then 6. So all element engaged here, first element. Okay, now domain, then range will be definitely second element. 1, 2, 3, 4, 5, 6. And I can't repeat, you know that. First element you can search. So what is a codomain now? So codomain is itself B, which is equal to the range this time only. So this is a simple question, but it's a meaningful question, so that I have explained here. Okay, now move on the some other question which we can see. The question is question number 6. Question 6 is find the domain and range of the relation defined on R equal to x comma x plus 5 such that x belongs to this. So this is a question where we have to find the domain and range. So I already have told you that whenever you find the domain and range, first it is a set builder form. You try to convert in a roster form. When you could find the roster form by viewing or watching that or looking that, you can find the domain and range easily. So while going on the solution, let me explain something. This is x and this is y. This time y terminology is not given, but one should understand it is y. You also can take as given that y is x plus 5. You can write, it is not wrong. And y is this element, second element. And when x belongs to this one, we are told that x belongs to this one. Okay, the restriction of y is not given to us. The restriction of y is not given to us. It is only told that determine the domain and range of the relation defined by R equal to this one when x belongs to this one. The second element, the boundary or the limitation or range of the second element y is not given. Only x is given. So we will find all the conditions just by this particular we can find out all. Like what? Solution I'll go with, given y is equal to x plus 5 we are given, x is equal to these element. So one can put here, don't go on the y because the second element y is not bounded by any particular set or the condition of y is not given here. So we will follow, we'll just check x is here, this one, and y equal to x plus 5. We can put 1 by 1 instead of x and get your y. So answer will be what? I think you can do by your own. Just put 1 by 1. I don't think that I need to tell you. Put, this is y, second element. Now when you'll start your r equal to, what you'll write? First you will take 0. Second element will be 5. The first order pair will be 0, 5. Then go with 1. Then 1 and 5, meaning 1 and 6 will be second element. 2 and 5 will be 7. 2 and 7. 3 and 5, 8. So this kind of all 6 element and their images write in the ordered pair, and it will be your final roster form. So I think you can make by yourself only. I have given the idea. This is x, first element, and this you should write y, and just put 1 by 1 instead of x and get your y and make a relation r in a roster form. Okay. So this was very simple questions I just explained verbally, and you do by your own now. So questions are now being so easy. Solve 6, 7, 6 already explained, 7, 8 and 9 all are so easy. One I just want to discuss with you. Eighth one. So question 8 is a is equal to x, y and z, and b is equal to 1 and 2. Find the number of relation from A to B. This question is very easy but meaningful, that number of relation we want to find from A to B. So let me explain that how we can find out number of relation. So I taught you that what is actually relation. One should know relation is a subset of A cross B. Relation is a subset of A cross B. So we first go with A cross B. So A cross B, how many element in A cross B, and then in A cross B, how much relation you can find out, how much subset you can find out. Relation is what? Subset of A cross B, subset of A cross B. So find A cross B subset. So A cross B is having how many element? So you know A having element 3 element, B having n of A is equal to 3, n of B is equal to 2. A having 3 element, B having 2 element. So n of A cross B having 3 2s are 6 element. So when you will find A cross B Cartesian product in the first exercise I taught, so you will have a 6 element. And then if I say number of subsets will be, you know that I taught you in the earlier chapter, number of subsets will be 2 to the power n. So this time answer will be 2 to the power 6, and 2 to the power 6 meaning 64. So I would speak that number of subsets is 64 and relation is none else, which is subset of A cross B. So if you compare these, 64 relation you can form from A to B. Just keep remember and keep in mind, meaning you have a A, you have a B. Now find A cross B, meaning Cartesian product, and in Cartesian product we have a 6 element. Number of subsets of A cross B will be, how we can find a number of subsets? So we can have a 2 to the power 6, 2 to the power n is a formula. So it is 64. A cross B's subset of A cross B is 64, and I taught you that relation is just a subset of A cross B. When you compare these sentence, you will have that 64, which is subset of A cross B, this much relation you can form from A to B. Even I haven't written even a 1, but you can form r equal to xy such that, and so on, r equal to different relation you can find which is from A to B. And how many relation you can find? 64, because 64 is what? Subset of A cross B. So keep remember, sometime it may ask that find the number of relation from A to B. So what you will do? First you will find A cross B, then find number of element in A cross B, then find number of subsets in A cross B by using this, and whatever the answer will be there, this much is a relation you can define from A to B, and that's all. So this is exercise 2.2 I've done here. Tomorrow I will start the important topic function. So now let's look what is there in the chapter. Thank you.